Hello, everyone. Today I'm going to be presenting my science fair project. But before we begin, I want to make sure we are all on the same page, quite literally. I'm not sure what you're seeing, but if you look below my abstract, you're going to notice there's a PDF. If you open that PDF onto another tab, you'll be able to zoom in and follow along when I present about each of the different sections. Now that we got that out of the way, let's begin with my science fair project titled Analyzing How Gender Affects Peer Conformity with Ash Suliman's Line Test of 1935. Now, I know that's kind of a mouthful, but this is basically the whole purpose of my experiment. In simpler terms, it's to analyze how gender affects peer pressure or peer conformity in small groups, specifically using Ash Suliman's line experiment in the 1930s. Let's talk a little bit more in the background about my whole project. So this project is based off Ash Suliman, as I said before. Ash Suliman created a classic social psychology experiment whereby he gave a set of males a line test that had an obvious answer. And let me just go over his experiment a little bit more. He had tested 9 males. 8 of those males were actors, and one of the males was a true participant. The true participant, of course, thought that they were just one of the many participants in the actual experiment, but that wasn't the case at all. So, what Ash Suliman did is basically he told the 8 actors whether to say the correct answer or incorrect answer depending on the question they were at. And from that, he found that about 1/3 of the true participants conformed to the majority answer. And this means when he told the actors to say the incorrect answer, excuse me, he was testing to see if the last or the true participant will say the obviously correct answer, or will they go with what the group said and say the obviously incorrect answer. And that's basically his whole study. Now, in my study, I'm doing the same thing, but I did a couple things different than him. First of all, one of the things I found interesting in his experiments is that he only tested males in their early to mid 20s. And I thought, what would happen if I do the same experiment, except I did it with all females? What if I did it with all males? What if I did it with a group of both males and females of different ratios? And that kind of gave me inspiration for my whole project as well as my 4 experimental groups, which is the all male group, the all female group, the single female group, as well as the single male group. And you can see these different groups if you look under the data in the middle of my poster board under experiment data. It's the 4 tables. It's represented by the 4 tables, I mean. And basically, to go over my experiment a little bit more, of these 4 groups, I have 6 trials in each group, meaning if you look at the different experiment data tables, you're going to notice that there's 4 of them, of course. And in each one, there are 6 trials. So you're going to notice in the all male group, there is trial name, males 1, males 2, and so on, all the way to 6. And what each trial is represented um, by figure 1, if you look just to the right of the all male group data table, you're going to notice that there's figure 1, of course. And this represents what my project actually looked like. So instead of having 9 people, because that's just way too much to manage, I decided to do 3 actors and 1 true participant. So about 4 people altogether. And of that, you want to make sure that the actors are on one side and the true participant is the last person to answer. Now, what I did with my experiment is, you can see in figure 2, I have an example of my answer, not answer sheet, but my question sheet that I gave to both the actors and the true participants. Now, what I had them do is I set the paper down in front of them and I gave them 3 minutes to answer. Now, what the true participant didn't know is that I actually gave the actors prior instructions. As you can see, just to the left, the right of figure 2, you're going to see the actors' set responses. So I went over with the actors. I made sure to tell them what questions to say the correct answer and what questions to say the incorrect answer. And so if you look at the actors' set responses, you're going to see what I told them to say incorrectly, or you're going to see the questions in which they answered incorrectly. You can see that with the table, the question number, the incorrect answer, what the actor said, as well as the correct answer right by that. And that's just a little bit of background with my experiment. Now, looking back at figure one, as I said before, there's three actors and the last person is the true participant. So after I gave them time to complete the form, then I started with the actor on the far left and I asked them to say their answer aloud, followed by the next actor, then the next actor, and then lastly the true participant will say the answer. And from that, I'm going to see if the true participant will say the correct answer or will they follow what the entire group ahead of them said, which is the three actors. And that's basically my methodology for the whole experiment. Moving on to my hypothesis, I said that if we're testing in a group of the opposite gender, then there would be a slight increase in conformity because there would already be an outlier in the group, thus promoting the need to fit in or conform. So in other words, to put this in simpler terms, I said that the single female and single male group would have a higher conformity rate than that of the all female or all male group. I forgot to mention that the single female group consisted of 3 male actors and 1 female true participant. Now, in comparison, the single male group is the opposite of that, in which it had 3 female actors and 1 male true participant. Moving on, the all-female group had 3 female actors with the female true participant, and the male had all males, of course. Moving on to my null hypothesis, this is stating that there is no difference in conformity between the all-female or all-male group and the single female and single male group. In other words, there is no difference in the need of conformity based on gender. The opposite is saying that the all-male or all-female group has a higher conformity rate than that of the single female or single male group. So that's basically my hypothesis, and I went over the variables a little bit as well as the methodology. So let's move on to the meat and potatoes, which is the data of my experiment. As I already mentioned before, you're going to notice that there's 4 tables, and these 4 tables represents my raw data from all of the experimentation. As I said before, I have my 4 experimental groups, but just noting a couple general observations and other things I noticed from all of the experiments is that, one, overall, a lot of the participants were actually really confused and showed a lot of hesitation when they were answering the questions, especially when on the questions I told the actors to say the incorrect answers. So it was really fun for me to actually see that kind of confusion and hesitation because this was a situation that, or an environment that I put them in and reacting to the variables that I was testing, which is really interesting for me to see. Another general observation, a lot of people were either confident in their answer being correct or overall just generally shocked, as I said before. There was a couple people that really just didn't care and they wanted to get it over with, which was something I didn't really expect. Just to point out a couple things with each of the tables, I have the child name, the rate of conformity, the question of which conformed to the group answer, as well as the observations. So you can give that a quick look over there. Just scanning through it, I already mentioned that each trial is represented basically by figure 1, as I said before, except trial figure 1 represented the all-female group, trial 1. In this case, figure 1 would represent trial 1, but in figure 2, I would have the same actors, the same testing form. The only thing that will be different is the true participant. And same thing with trial 3 and 4. Everything is going to be the same, but the true participant is different. And that's basically how I did everything. Now let's move on to more of my analysis right now. So we're looking at the conformity rate pie graphs, which is located on the right side of the data section. I know the titles are a little bit hard to see, so please bear with me with that. But in that little box of the conformity rate pie graphs, you're going to notice on the top left, that's the all-male group. On the right of that, that's the single male group. On the bottom left, that's the all-female group. And on the bottom right, that is the single female group. So let's just go over a little bit more about what this means. So I decided to do these pie graphs in order to see the conformity rate much easier than looking at the raw data table graphs. Now, if you look at the colors, the light purple color or pink color is those that did not conform. The vibrant purple is those who conformed twice, and the dark purple represents those who conformed only once. Looking at the all male conformity rate, there was 2 people that did not conform, 2 that conformed once, and 2 that conformed twice. To put this in simpler terms, 4 people conformed while 2 people did not. Now, comparing this with the single male group, it's exactly the opposite, because in the single male group, there's 4 people that did not conform and 2 people that did conform, which is the opposite as the all male group. Moving on to the female and single female group, you're going to notice that the conformity rate is the same, because in both groups, 3 people conformed and 3 people did not conform. And that's basically my conformity rate pie graphs. Moving on to my statistical analysis, which is a right-tailed t-test comparison. You would use a right-tailed t-test comparison when you're comparing 2 groups, and you think that group 2 or group B has a higher value than that of group 1 or group A. And I decided to use this comparison because my whole hypothesis is saying that group 2 or group B, which is the single female or single male group, has a higher conformity rate or has a higher value than that of group 1 or group A, which is the all female or all male group. And that's the whole reason why I use this right-tailed t-test comparison. Now let's go on to the t-test distribution for males first of all. You're going to notice the graph to the right has a little red area all the way to the right. This represents the rejected. And what this means is my whole hypothesis, or my saying that the second group, which is a single male group, has a higher value than that of group 1 or the all male group. This is actually incorrect because, as we see by the graph, it is rejected. So my hypothesis, of course, is rejected. You can also see this with the with the graph to the left, and you can see that the rate of conformity overall is very different. The all male group has 1, while the single male group has 0.33. Now, moving on to the female t-test comparisons. Again, looking at the graph, first of all, you're going to notice that all the way to the right, there's a little red area, and of course that represents the rejected. And in this case, it is rejected because the single female group does not have a higher value than the all female group, and this is because both of the values are the same. And you can see this by the graph to the left, and you see that both of the conformity rates is 0.5, or about half. So moving on to my conclusion, because that was basically my analysis. As you already expect, my hypothesis was rejected, unfortunately. Instead, the male supported the alternative hypothesis, in which the all-male group had a higher conformity rate than that of the single male group. In comparison, the female supported the null hypothesis because, there was no difference in conformity rate. And this means that if a female was put into the group of all females or a group of all male, gender does not really play a factor in their need to conform or fit in, if that makes sense. Let's move on to some of my errors in this whole experiment. For one reason why the all male group, looking at the conformity rate pie graphs, the all male group has a really high conformity rate in comparison to all of the other groups. And this could be because in the all male group, I took participants that were younger, in a different grade level, and in a different academy than I chose everyone else from, my other testing groups. I did this because I was running out of males in my experiments, and I was really desperate to try to find male participants. So to find those male participants, I went into different academies as well as different grade levels in order to fill that need in my data set, if that makes sense. And this could be one reason why the all males has such a high value in comparison to everyone else. So in the future, in order to improve this and make sure that this data change does not actually happen, I want to make sure that all my participants are in the same grade level, are around the same age, at least like 17 or 18, or just a gap of no more than 2 years, as well as make sure they're all in the same academy so my variables are really controlled, and in order to test the gender very specifically and not have other factors affect my results, if that makes sense. Moving on to not necessarily an error, but something I need to be more aware of is the confidentiality among participants. Although I did stress the fact that the participants should not tell anyone what happened in the experiment, nor should they tell any of their friends, especially if they are taken from the same classroom. I did try to stress this fact, however, most likely there were a couple people that talked and told their classmates what to expect, and this could affect my overall results of the experiment because to the people that do know what the experiment is about, that could affect their true reactions to the questions that I ask them. And that's something I just need to be more aware about in the future. Moving on to more improvements, one thing that I could improve is having a more controlled testing environment. Because I didn't want to, excuse me, I didn't really want to bother my participants too much, I actually brought my experiment to them. So there was one day I was in the library, another day I was in um, excuse me, an empty classroom, and another day I was actually outside of the classroom on a bench doing my experiment. And this is because I didn't want to really bother my participants. However, in the future, in order to control the variables more, I need to make sure that, excuse me, I have one set environment in order to test all of my experiments to just control the variables a bit more. As I mentioned before, another improvement I could make is having a form to identify participant factors that could affect the experiment. I mentioned before about age, as well as grade levels, as well as academy. But with a form specifically for the true participants, I could ask for their age, grade level, race, relationship with the actors, as well as other personality traits, like whether they would classify themselves as an outgoing person or a leader in comparison to a follower or someone that just goes with the flow. And this could help me to kind of expect or suspect whether they will go with what the group says or whether they will say the obviously correct answer in the future. Now, moving on to further research. Further research should be conducted to further analyze what affects peer pressure. Peer pressure is very important in our society, specifically in the education system, as well as child growth. Um, we should we should know what affects peer pressure more because there's a lot of factors that could affect peer pressure. Peer pressure is involved with bullying as well as as well as child growth. Um, a couple things that we should test to see what affects peer pressure is age, grade level, race, social background, as well as the personal relationships with the actor. I specifically wanted to do age before I even started my entire experiment, but I couldn't really do that because I would need to go into the different grade levels and actually um, test them out during school time, which I just couldn't do. But one reason why you would want to try and test out age is because you might notice when children are very young, maybe 5 or 6, they don't really have a need to conform with the group or the need to follow what everyone else does. You will notice that a lot of children are very outgoing and they just do what they want and they don't care if what they say is wrong or incorrect. However, when they start to slowly grow up, that kind of trait vanishes and slightly a fear starts to build in them and they want to actually conform with the group. They don't want to raise their hand in case their answer is wrong and other things like that. And I found it very interesting about why this would happen and like when does the need to conform actually happen in that age group or in a specific age group. So that's something really interesting that should be tested out and that could be tied in with the grade level as well. When we're looking at race as well as social background, we're talking about different ethnicities, and other physical characteristics that you can see, as well as the social or economic background or social stigmatisms or that people have of a specific ethnic group, as well as just the way that people carry themselves. So those two would be a very interesting thing to study more so in the future. Finally, personal relationship with the actors. This will be very interesting to see how the brain works a little bit more, because if we run the same experiment, except the actors are people that the true participant knows versus just random people on the street, would the true participant be more inclined to follow with the actors that they know, or will they be more inclined to follow what the strangers say in order to fit in with that stranger group that they don't know? And that's also just a very interesting thing that we should study in the future. Overall, this is my project about analyzing how gender affects peer pressure with Assalomon's line test of 1935. Thank you so much for listening, and I'll be happy to answer any questions you have. I'm not sure how we can get in contact, but please reach out to me if you have any questions. Thank you so much and have a good day.